This may be somewhat of a mislabeled talk in a way. I'm not going to focus as much on the humanitarian aspect of this. I will give a demo for how we use this technology in our humanitarian applications. But if you're looking for more of a humanitarian focused talk, then I won't feel offended if you want to leave. This is quite a technical talk about something I'm quite passionate about. What I think is a bit of a paradigm shift in how web software can be developed. Second caveat as well, I tried to be clever and make a terminal-based presentation. Doesn't work so well on this kind of setup, so I've just exported as HTML. There's some formatting issues, but it does the job. So, okay, what we're going to cover, Postgres in the browser, why we may want to do this, key facilitators that have enabled this as an option. Going to talk about a project called PG Lite, and then how we use PG Lite at the Humanitarian OpenStreetMap team. So why would we want to use Postgres in the browser? Again, sorry, it's a bit text heavy. This is supposed to be animated, but we are where we are. So if you can load Postgres directly into a web browser, into the client side, where most users interact with your application, you can use SQL directly in the browser. So one thing that this is great for is code sharing between, you write your backend queries in SQL. You can equally use exactly the same SQL directly in your front end. You no longer have to, manage JSON files and parsing and trying to make your own data structures in different ways. You can just directly query a database. You also unlock the power to use extensions built into Postgres. One of them, obviously very relevant to this conference, is PostGS. So you can use all of the geospatial processing algorithms directly in your browser. Right? So this is still, again, many caveats in this talk. This is yet to fully come to be. There are many extensions that are capable or are currently supported within PG Lite, but PostGIS is not yet one of them. But it's hopefully pretty close. It also enables local first software development. So that's really what I just want to quickly cover now. What I think is kind of the future of where web development may be going. So local first software is a pretty big movement in how things are done for web software. I'm not going to cover all of the ins and outs. There are many things that come under the umbrella of local first. One of them is offline first. But there's a few conferences that talk about this. There's lots of talks online. If you go to lo-fi.so, you'll get a lot of info about local first. So, but just as a rough introduction, this is your traditional application, right? That pre-web days and like collaborative, web technologies. You just have your software. It's on your device. You work offline. You own it, but it's a single user experience, right? Your data is just on your device. Then enter the cloud era. You start to have more collaborative interactions, right? But this is all mediated by cloud servers generally, right? You have a server somewhere that people are accessing. You need to call APIs. You might have loading spinners. You need to manage state in the front end. There's all of these complications that come with it, but it's unlocked a lot of powers, right? Which are particularly around collaboration. So local first is a merger of two approaches where you're developing an application that works fully offline. The data is owned by you. It's on your device. You're not querying a cloud server. If the server goes down for some reason, right, it's AWS, whatever it is, you can still use your application. You can still access your data and run your tool. But at the same time, you still get the multi-user collaboration aspect that you expect from web software. And the way that this can work is using sync engines. So there's this piece that fits in the middle that I'm going to talk about in future slides, is the sync engine. But before I talk about that, I'm just going to talk very briefly about state management. So for web software, you generally need a way to communicate state from the back end to the front end of your web application. So for example, this might be user information or project information, geospatial, whatever, but you need a way to get it to the front end to then store it in the front end and then display it to the user. So the most traditional way to do this would be using forms. I mean, this is the first iteration of the internet, right? You send a HTML document to the users, they render that in their browser, and it already has the information injected in. So if you want to update the data, you have to refresh the page. Ajax changed that. You can start to do small amount of dynamic of content in your page where you can fetch from the server new data and update part of the page. Now, 2005, REST starts to become a thing. So REST, it's kind of the de facto standard for like lots of tools these days still, 20 years later. It's just a specification for how you should write backend APIs so that front ends can easily consume that data. And generally, that might be JSON data that you're grabbing from the backend, storing it in your front end in some form of state management, and then dynamically updating your page. There's been a small refinement to that with GraphQL. So GraphQL allows you to more selectively grab the data that you need exactly from the backend. Rather than grabbing, like, say, an entire row of data, you might just want to grab a few fields. And GraphQL allows you to just specify exactly what you need. Now, local first is a complete shift away from all of these mindsets, and it fully abstracts away any form of state management in your front end. Essentially, you're replicating a subset of exactly the same data that's on the back end in the front end. So then you can just query it directly like you would on your back end. So I mentioned sync engines. None of this would be possible without some way to transfer the state from the back end to the front end and then reconcile changes between them. But now with sync engines, you can have applications that have no backend API whatsoever. You just have a backend database, or say backend, but just a database on a server that has your data, and a sync engine in the middle, and then just your front end. And many clients will connect via their front ends, via the sync server to the database. So yeah, this is the key innovation that I'm talking about here. And I'll talk about a few options for how to do this. There are many organizations and like products that offer this, open source tools that offer this. So Postgres in the browser, key facilitators that have led us to this point. WebAssembly, right? So I'm going to talk about four things, right? Four facilitators here. WebAssembly is number one. Came to be about 2017. Allows you to run basically backend, what is perceived as backend code in your web browser. So you can run C code, you can run compiled C++, and Rust and Golang are even supported as like compile targets. So you essentially compile to WebAssembly, and then WebAssembly is the thing that runs in the browser. Obviously, tools like Postgres are written in C, so you can, and other tools like SQLite, many database things are in C, so you can, in theory, compile these software tools to WebAssembly and then run them in a web browser. Databases. So this is exactly what I'm just describing here. Tool called emscripten allows you to compile C libraries into WebAssembly and potentially port many of these existing, very stable, mature technologies that are available in C to run them directly on your web browser. So SQLite has been supported for quite a while in this way. Postgres is quite a new venture for this. There's a team at Electric SQL that are developing a project called PG Lite that I'll talk about in a few slides. Third thing that's enabled this is conflict-free replicated data types. Now, these are essentially a data structure that exists in your database to allow for very sophisticated conflict resolution. If you think you're completely removing the back-end portion of the API and you're interfacing directly with the database, if many users submit data about the same entity within the database, there may be some form of conflict that happens. So this form of data type really helps to automatically resolve this kind of conflict. This is came from obviously academia. It's a reasonably new concept in software, like actually coded software. But there are a few projects that can map CRDTs to Postgres data types, so you can actually use these in your project. The final thing that I'll mention, more on the humanitarian aspect, is global smartphone adoption. Obviously, this is not so much of a concern for us here in Bosnia, but in many regions of the world, there's not great mobile data connections or any mobile phones at all. So there's been a huge increase in smartphone adoption. We're about approximately 57% of the world's population. A very rough estimate, have a smartphone these days, and this can be determined from connections to mobile cell towers, right? So generally, GSMA here can do a rough prediction based on how many people connect to data. One region that still has pretty poor connection, I think they should say 27% of people are not connected in sub-Saharan Africa. So there's many regions of the world that have pretty poor connectivity still. But you can see from this, hopefully see from this graph, might be a bit small, but the red line here shows from 2015, from just over 30% of the global population being connected, up to 2023, just under 60% of the world is connected. And when we say connected, this may mean, these are estimates obviously from one phone being connected. Often in a household, you may have one phone user and many people are able to access that phone, just as the same for desktop computers back in the dial-up days and where you had your one computer. So the estimates may actually be higher for how many people can actually access a phone. So introducing PG Lite as a project. This is where the magic is, the Postgres in a browser that I'm talking about. So this is a WebAssembly version of Postgres. There have been a few previous implementations of this using virtual machines in the browser, but this is a pure WebAssembly implementation built off the C code Postgres. So it's pretty performant. Storage is quite a key consideration though, right? Obviously with databases, you need to think about where is the data actually stored on the file system. In a web browser, you have more limited options here. So there's something called IndexedDB that's built into every web browser, very ubiquitous support. And there's a small shim for that can allow you to store the data there. There's also more of a newer thing, the Origin private file system. I don't know how many people know about this, but it's a sandbox portion of your file system that's available to your web browser for a specific website that you're on. So this opens many possibilities, and there's a lot more development down that road. So I mentioned obviously bundling PostGIS in your browser. You can just think of all the possibilities of what you could do on the client side. Rather than having to have a server where you do your geospatial processing and send the final data to a user, you could, on a much cheaper and smaller scale, just send your data directly to the user and they can process it. Use all of the geospatial processing algorithms available on their browser, built into PostGIS, and get the output that you need. So we're using this at the Humanitarian OpenStreetMap Team. This is an example of a very simple offline data collection tool. You can work fully offline because you obviously just have the database on the device. You get instant, real-time inserts and reads. You don't need to wait for loading spinners, and it's a very nice user experience. But then when you're working offline, you can store it in your database. You have this sync engine that's available in the middle. When you come back online, you can then trigger the syncing and then this is where you invoke the CRDTs and the conflict resolution if people affect the same data and so on. So yeah, collecting data in the field in a way via the web can be a lot easier with this approach. So I'm actually just going to show a very quick example of this. If you don't believe me that this kind of thing is possible, PG Lite, they offer a little playground. This is Postgres running in a browser. I'll copy this in. I'll create a table. Where was I? Sorry, it's going to be a bit. I'll probably just. I'm just going to insert two records here. So create a table called cities with name text, insert some values. Obviously, this is all happening directly in the browser. And then let's just do a select of the data. So yeah, back on the mic, sorry. So I've just inserted some data and read some data. Very simple example, but you can see we're running SQL directly in the web browser. And yeah, this is how it works. So very brief final part, our usage at HotOSM. The field tasking manager, we're starting to implement, or we have implemented this approach. Those that attended the thing this morning, there's definitely some refinements that need to be done to optimize the tool in general, but this is the approach that we're going for. Right, so we use we use PG Lite embedded into the like the front end, and then we use Electric SQL as a sync engine between the two. So now this unlocks two capabilities. One that I mentioned already about the collecting data offline and being able to sync when you come back online, but it also enables real-time sync. So the sync engine can also operate as a way to propagate your data out to multiple users. So say the user in one location collects data for a building, and then the building turns green in your application, which it does in FieldTM. Every other user should then have that information propagated out to them. So on their device in the field, and if they're online, obviously, they'll just immediately see the data updated, and the building turns green. You can obviously have real-time notifications. You can have all of these real-time events that happen just by virtue of updating your database and having the user read the database. So I was just going to very briefly show this kind of thing happening. So this might just take a second. So one of the limitations or downsides, I should say, of this approach is obviously you need to load a few slightly heavier libraries at the initial load. It obviously affects your first contentful paint. These kind of metrics that UI designers like to throw out there. On the first load, especially if you need to grab some data from the backend, load it into your database, you may need to load a few megabytes of data right at the start. So it affects the user experience in that way, but then the subsequent load shouldn't be affected in that way. So if I click on an area here, you can already see there's some green buildings. This is what I was just describing. Yeah. I just need to upload 2 pages. Just bear with me. I hope this is going to work. Okay. So now I'll click on this building, and that's this building over here on the left. I'll collect some data, fill out my form. I won't fill it all out, just to, so this was, a user collecting data in the field, updates, and you can see on the left, the real-time sync has occurred for the second browser or the second user. So yeah, that's just obviously very simple demo, but you get the idea. And that's the end of the talk, pretty much. So yeah, hope this has been useful, and you might start to implement local first software development in your approach for web development, and maybe attend some conferences for lo-fi, and yeah, might see you around. Thank you.